That's mass kilograms per meter minus kilos. This change should be. No, sorry, change. Can you go somewhere? And the next one also. How are you following? You're not just doing it mechanically. Why are you doing this? Make sense? Okay, so we are going to stop and start with a new topic. Or we should put some deadline for something. So let's say once everyone finishes finding that number, we stop. We do revision of another topic and then come back after 1 hour. Okay? So everyone should get the total mass and then we stop. Anyone who is not found total mass, can you raise your hand? I can come and help. Everyone is found it? You haven't? You need help? I'll come. Go supply and supply. Okay, let's get that done for both of you, and then others you can continue solving till then while I'm helping, but then we can go to. Okay. Now, just hint for the others who have found that mass to convert it to volume. One of your classmates asked me a very intelligent question, saying, will 1 kilogram of water be equal to 1 liter of water? And I put the question back to the student, and it's back to you as well. At what condition 1 liter is equal to 1 kilogram of water? At room temperature, like at 20 degrees Celsius? What happens if it's at 40 degrees Celsius? If water is at 40 degrees, will it still be 1 kilogram equal to 1 liter? Think. That's the hint. So your volume is not going to be 0.839 in this case, it will be different. It might be low or high. Think. Yeah. Anyway, you want to make the question over. Also CP. Anyway, you want to add 2, 3, 5% of it. So that's what double click that. It's probably out. What is E and G? E is that? Yeah, okay. So let's go. Let's see if you've done the one with you. That's why you assume it to be, but you still need to consider, so somewhere it's missing, some of the values are missing. Yeah, but some of them are missing, so I would say some of both is missing. So come around and delete. This one, this column. Has everyone got mass, total mass? One more remaining? No? Important. Some of force apply or under supply. Total volume? Figure it out? Yes. Yes. Almost. One more minute and then we'll start. One more. And also that is for 4-1, it should be 4-1 kilograms. Yeah. Why do I know? You already converted mass. After the TFDS. And then can you do the sum of both that? It should get the same number. The same number you got. Okay, you can stop working on your assignment. We'll start with this new topic. Okay, I think maybe 3 weeks back, Raj has discussed psychometric applications, which is basically air and moisture mixture. Very important. Definitely one question in assessment 4. Okay. So stop solving your assignment. Definitely I will help you afterwards. Okay. Because this I cannot help you with the assessment 4 when you're doing it. It's a final exam. Okay. With assignment, I will be there guiding you, because assignment is more formative assessment where you're learning while you're solving things. Assessment 4 is a summative assessment where we're going to test how much you have understood over last few weeks of the semester. So, what's meant by psychometry? Can anyone tell me what's meant by psychometric applications or psychometry, or what is that science? It's dealing with, that science deals with what? With air. Any specific type of air? Is it dry air or moist air? Psychometry deals with dry air or moist air? Moist. Most of the time, moist air. Now, I'll show you a psychometric chart. You have already seen this before, used it before. Have you seen this before, a psychometric chart? Now, on there, most of the points on that chart are dealing with moist air. There's only one point, which is right at the bottom there, which will be completely dry air. Now, you see that humidity ratio is not very clear. Humidity ratio, what it tells you, how many grams of moisture, which is water, H2O, how many grams of H2O is present per kilogram of air. So that horizontal line would represent any point on that line, 10 grams of moisture every kilogram of air. If we continue to go down, there's only one point, that point where there will be 0 grams of moisture. So there's only one point on this entire chart really, or one point on that one line along that entire horizontal line. There's no moisture, but most of the other times there will be moisture. Okay. Now, most of the times we will be dealing with adjusting the moisture content within the air to make it suitable for either human consumption, like air conditioning here, because outside today is quite humid. Here, it's not that humid. It's cold, the air is cooled down, but at the same time the moisture is controlled. How is done that? How do we do that? By manipulating the air, either by heating, dehumidifying, humidifying, or cooling. One of those four individually, those four processes individually or combination. And that's basically psychometry. And there's big industry everywhere, especially in Singapore, I'm very sure. Any of you work in building services industry? I'm surprised. That's a big industry, building services. Anyone works with HVAC, heating, ventilation, air conditioning? Here? No? Do you know anyone who works within air conditioning industry? Yes? Ask them. It would be a very good contact. Not industry who makes air conditioner, not necessarily making those air conditioning units, but application. So the companies like ARUP, for example, ARUP, it's a multinational company. I'm very sure they have got an office in Singapore. And what they do, they hire engineers, mechanical engineers, and the job they do is designing HVAC system for big facilities, for this building or any new construction. So wherever there is a new building coming up, you should go, hooray, yes, there's plenty of jobs for mechanical engineers. Why? Although civil engineers are building the building, but their job ends as soon as the building is constructed. Civil engineers, they are no more needed. Now, for the rest of the life of the building, for maintaining, for updating, is mechanical engineers. Water supply, air supply, all of that, hydraulics, everywhere mechanical engineers. So we have got ongoing job, and that's a very good thing. Right. Now, what would you be doing? A lot of times, technicians will come and try to fix if something is not working. But on the back end, as an engineer, what we will do, we will monitor these systems. I'm not very sure whether this building has a smart building management system, but a lot of modernized buildings, they have got a smart BMS, building management system. Most of the buildings will have a BMS, building management system, but smart means the sensors will be interacting and recording the data on the cloud somewhere. And so your job will be, maybe you're not living in Singapore, not in this, you're living somewhere in Queensland in Australia on the Gold Coast, in a big mansion, and working from there, monitoring 10 buildings in Singapore, how's the health of the building, just temperature, pressure, humidity, everything, and you would be then any calls that escalated. So occupants of this building, let's say things are not working, it's getting too hot and humid, one of you or me or someone will go and lodge a complaint. As soon as that complaint is lodged, someone sitting far away will monitor data, diagnose. They're doctors, like we are doctors. Engineers are doctors of machines. Always remember that. What we do, doctors feel the pulse. You've got a stomach upset, some bug. That's what they say. What do we say? We look at the temperature, pressure, humidity, all of that, and say, most likely the filter is clogged with some rubbish, or the blower is not working well, or the refrigeration chiller system is running low on refrigerant. Okay? These are the things that we diagnose. And how do we diagnose that? By just identifying pressures and temperatures and humidity. So, for example, if we are expecting the moisture content to be reduced from, let's say, 20 grams to 10 grams, and your sensor is not detecting that, there are a couple of possibilities. First possibility is definitely the sensor might be faulty. But then if we are getting a complaint from the occupant saying it's getting too humid, too uncomfortable, so definitely the sensor is not faulty, because humans are also feeling that. So then most likely cause is, what type of dehumidification system do we have? Are we chilling the air? Are we cooling down the air to its dew point temperature to remove the moisture? Or are we using chemical desiccants? Have you heard of chemical desiccants? What's meant by a desiccant? What do you mean?
Take out the moisture.
Take out the moisture, yeah? And can you give me an example of a desiccant that I'm very sure each one of you have handled once in your life, and maybe once in the last 6 months, if you have bought a new electronics? Silica gel. Like all the electronic packages, you get these small pouches, do not eat. That is desiccant. Table salt, sodium chloride, is a very good desiccant as well. But it's corrosive, so hence it's not used. This metal starts corroding. So desiccant absorbs moisture, but then once it gets saturated, it cannot absorb any more moisture. So if you are using a desiccant-based dehumidification system, then so you would know what kind of system is there, and you would identify the possible cause of the fault, and you report it to a technician. Technician will know exactly what might be wrong, focus their efforts on one or two things, and try to fix it. So your job is, as a doctor, to say, okay, that's the fault, and the pharmacist will go and give the medicine. So the technician will be kind of a pharmacist. Make sense? So I'm going to ask you some questions in there, and let's try to answer them and try to think. We have already answered that. So activity deals with mainly dry air, but you could also say number 3, both dry and moist air. Is it mainly dry air? Only one person. Good. Is it mainly moist air? Okay. So it's mainly moist air, or you can say moist and dry, both of them. Because there's one row which is completely dry at the bottom. Third, is the air in this room dry? True or false? False. Good. Moist. So now the questions are getting trickier. Partial pressure is equal to something multiplied by the total pressure of the mixture. For that, you need to understand what is total pressure. Yesterday, I made a little bit kind of a brief introduction to that as well. Can you tell me how do you define total pressure? Okay, so let's say you have got only one type of gas in this room, only oxygen. There's no other gas in this room, and we are not there, we are outside. And walls are impermeable. Impermeable means there's no leak in the wall, there are no holes, nothing can come in or go out. Everyone can visualize that? Now, only oxygen molecules are there, and they're exerting intermolecular forces, attraction or repulsion against each other, against the wall, and that's why all of those together are experiencing some pressure. If you connect a pressure gauge on the wall on the outside, you would see it's reached some pressure. It's not absolute vacuum because there's matter inside, there is some pressure. Now, if you add one molecule of nitrogen in there, in this room, one additional molecule of nitrogen, and record the pressure. Now remove that molecule and add one molecule of oxygen, only one. So earlier we added one molecule of nitrogen, we recorded the change in pressure. Now we remove that nitrogen molecule, we added one molecule of oxygen and monitored the pressure and recorded it. Would those pressures be exactly the same? The new pressures, when we added one extra molecule, would the pressures be the same? Why not? Okay, molecular weight difference, size of the molecule different. Also, not just molecular weight, but intermolecular. The way a certain molecule reacts with certain other molecule, whether nitrogen molecule attracts the oxygen molecule or repulses it, that all of that mechanics at molecular level changes things. Right? So, when we have this extra molecule of nitrogen, one molecule of nitrogen in this room, the partial pressure of nitrogen will be equal to something like, if you remove all the oxygen and leave only one molecule of nitrogen inside this room, whatever pressure it experiences, that will be the partial pressure of nitrogen. Whereas when you remove that nitrogen and leave the oxygen in there, which was the original pressure, that's the partial pressure of oxygen. And the total pressure is the new pressure, which has increased a little bit because of that extra molecule of nitrogen added. That's your total pressure. Make sense? Everyone? Lost? Lost? Maybe another simple example, because then I can see some of you are struggling to visualize billions of molecules. Let's think about, you've got a bottle and you add maybe one egg in there, in the bottle. Imagine there's no air inside there, just there's one egg. Now you add one more egg in that bottle. I'm talking about boiled eggs, okay? Shells have been removed, so they're not going to crack and they will be like spongy. And they're pushing against each other. So you have put in one more egg. Now, when there was only single egg, it was experiencing some pressure. When you have got two eggs, some different pressure. You keep adding more and more. How much, what, pushing them in. And they're increasing, the amount of pressure they're experiencing is increasing. Right. Now you try to add in the same bottle a watermelon, a bigger molecule. It's going to be a lot different pressure as compared to 2 or 3 eggs. So, but the total pressure will become a combination of all those molecules together. So that's the total pressure of the mixture. Whereas individual partial pressure is if only one of them was there. So if only watermelon was there, without eggs in there, or only 5 eggs or 4 eggs, whatever number of eggs, without the watermelon, individual pressures, how much they are going to experience. So what is that blank? To estimate the partial pressure, I mean the analogy, the example I gave you was so simple and maybe not really practical, but simple enough to help you give me the answer for this question. So, what was determining the pressure of watermelon or eggs? Was it the number of, so let's focus on watermelon. Partial pressure of watermelon, was it dependent on the number of eggs or was it independent of number of eggs? When we remove the eggs and only left the watermelon inside that bottle, whatever pressure the watermelon experienced was the partial pressure of the watermelon. So what should be that blank? It should be the number of that particular particles in the total. So it should be some kind of a fraction. That blank should be a fraction. What fraction would it be? How much mass of a certain substance is in the total mixture? No, fraction. Not just density. Because density will be density of everything together. So it has to be unique density. Or instead of density we call it mole fraction. How many number of a certain particles are present in the total? How many number of moles are present of a certain gas? So let's forget about eggs and watermelons. Let's come back to oxygen and nitrogen. If we have oxygen and nitrogen in this air, the air we are breathing, we have got oxygen, nitrogen. The amount of oxygen in moles compared to the total number of moles of the mixture will tell us the partial pressure of oxygen. The amount of or number of nitrogen moles of nitrogen divided by the total number of moles, that gives you the mole fraction of nitrogen and help you find partial pressure of nitrogen. Make sense? So that's mole fraction. Everyone understands what's mole fraction? You remember chemistry? A little bit? No? I mean, for just conceptually, it's kind of similar to mass fraction. You can compare it to a mass fraction. But it's not. It's number of moles is different. A little bit different, but it's basically number of particles. Okay? Now, humidity ratio is equal to mass of water vapor divided by mass of water. Humidity ratio. Yeah, someone said air. So humidity ratio is mass of water vapor divided by mass of air. Is that correct? Is that correct rather than correct? Is it complete? Air is correct, but is it complete? Is it saturated air or dry air? Remember now? It should be dry air. So how many grams or kilograms of water vapor is present in how many kilograms of dry air? That ratio is called humidity ratio. Make sense? Humidity ratio. Now, what are the different names? What else is, humidity ratio is also called as absolute humidity and specific humidity. So these are different terms. Why, as an engineer, why do we need to learn these? You don't need to memorize these, but you should know there are different names for the same property. Because you see, I'm teaching you something. Basically, I'm teaching you all the different names, but in the industry, you're dealing with, let's say, an engineer from Netherlands, and they only know specific humidity. They've only been taught this term, specific humidity, and they're trying to communicate with you. Oh, the specific humidity of this is so much, and hence this is happening, and you try to figure what? I've never heard this term. I've only heard of humidity ratio. That's the communication gap. But having that knowledge, you might at least ask the question. You might not remember exactly everything, but that would be where you should ask the question to that person. What do you mean by specific humidity? Can you put a unit in front of it? For all of that, unit is grams or kilograms of water every kilogram of dry air. Once you know the unit, you're talking about humidity ratio. Is the one and the same thing. If you ask me why that different names, people around the world, they use different names. Why hasn't it standardized? I don't know why it's not standardized yet. It's not that critical to be standardized. Otherwise, other things are getting standardized. Okay, so then we went through, in my lecture recording, I went through how to get partial pressures and of different species within a mixture, and especially for moist air. If you want to find partial pressure of dry air and partial pressure of water vapor, that's how you do it. Okay. And then we also came up with the equation, this equation for humidity ratio in terms of partial pressures and total pressure. So PV is the partial pressure of water vapor, and P is the total pressure of water vapor. Now, you don't worry about all the other things, okay, for now. I'm trying to simplify the whole thing just to help you use these for applications. How easy is it to measure atmospheric pressure or the pressure of air in this room? How would you measure? If I ask you to measure the pressure in this room, what would you do? Using the technology you have. I think most of your smartphones these days, they have got a barometer app. There should be a barometer app on most of the advanced. Mine one doesn't. But I think iPhones or Samsung S series Galaxy, they should have those barometers. If you're working in industry, definitely you will have a handheld digital barometer. So if you just place it on in the room, press a button, it will read how many kilopascals is the pressure. When it's reading pressure in the room, what is it reading? Which one of those? What are you reading? Are you reading PV or P? P. That's correct. You're reading the total pressure. Because barometer doesn't know how much more water molecules are there, how many air oxygen molecules are there, nitrogen molecules. It's just total pressure, whatever pressure the sensor is sensing the total, it just gives you a number for total. Now, how would you convert that number into partial pressure, either PV or humidity ratio, omega? How you can estimate one of those? Because why do you need them? Why do you need to estimate these numbers? As an engineer, if you want to diagnose things, you need to know what's happening by just knowing a couple of properties. You should be able to estimate the other properties and then make your decision based on that. You might be responsible for not just for monitoring the health, but you might be responsible for designing a building management system where you have to write some code, maybe in MATLAB or some other language, maybe most likely Python or C or Java, some maybe as well if it's an internet connected app. And in that code, you have to use these equations, basically converting one property to another property. What are you going to? What the sensors are going to measure? Temperature, pressure, volume, or specific volume. It might within the temperature, sensors might measure dry bulb and wet bulb temperature. Now, what's meant by dry bulb and wet bulb? That's the next thing. Do you remember what's meant by dry bulb and wet bulb temperatures? I'll just skip through that for a second. Before I go there, can you tell me what's meant by dry bulb and wet bulb temperature? Anyone? Any idea? No? Have you used a thermometer before? Yes? Thermometer or some kind of temperature sensor? And what do you think it reads? What temperature does a normal thermometer read? If you leave a thermometer on the bench here, what type of temperature would it read? Dry bulb or wet bulb? Dry bulb. Remember, dry bulb. The meaning, dry bulb. Now, can you visualize a thermometer? How it looks like? There's a glass tube, and there's a small bulb at the bottom which has got some kind of fluid. Sometimes mercury, these days is banned because toxicity, maybe alcohol. So some kind of red or green fluid inside which goes up and down depending upon the temperature. That bulb, when we leave it anywhere, it's exposed to air, and on the surface it's dry. Basically, there's no water on top of it. So if we just leave a thermometer on the bench, it will read dry bulb temperature. Now, how would you measure a wet bulb temperature? What you do, same thermometer, you put a small piece of cotton or a face tissue paper on top of it and put few drops of water, make it moist. So moist cotton or moist tissue paper or some kind of a cloth which will hold some moisture in it, and then leave it on the bench. So get two identical thermometers, one without anything, just dry, empty, and one with a small piece of wet cloth on it at the tip. Now tell me which, based on your intuition, based on your experience, which one of those would read higher temperature relative to the other one? Without the wick, without the wet cloth, or with the wet cloth? Dry. Dry will read higher temperature. Wet will most likely read lower temperature because it's wet, it's going to cool down, and that's exactly what it does. And that's exactly what we want it to do, because then it helps us to estimate. Now, how much low temperature can it read? If you keep pouring more and more and more water on top of room temperature water, okay, on top of that tip, can it read negative 40 degrees Celsius or negative 50 degrees Celsius? What's the lowest temperature do you think it can read? Temperature? Just temperature of the water? It can read temperature lower than the temperature of the water, few degrees, and that will be the wet bulb temperature of the. And that's how evaporative cooling systems work. In Singapore, they are useless because of the outdoor air has got so much moisture in it. I don't think you would have ever seen an evaporative cooler in Singapore. Do you know what is an evaporative cooler? Most likely you don't know. What's an evaporative cooler? Have you been to a very dry place but very hot? Any one of you travel? No? When it gets very hot, maybe it might work sometimes here as well. Very hot. Do you sprinkle water on your face to cool yourself down? What does it do? Why does it cool you down? Evaporation, but what's the effect? I mean, when water evaporates, what it does? It absorbs thermal energy from the surface and use that to evaporate. That's the latent heat of evaporation, vaporization, very high. And can it happen continuously? Can you continue to cool down yourself by spraying cold water on your body, or is there a limit to how much you can cool down? And that limit, yes, there is a limit, and that limit depends upon if the surrounding air, how much moisture is there in the surrounding air. If surrounding air gets saturated with moisture, doesn't matter. I mean, how much water you sprinkle is never going to evaporate because air cannot absorb any more moisture. Rather, you'll just start sweating, and that's what happens. I mean, you don't even need to sprinkle water on your body. Human bodies are so smartly designed by nature that why do we sweat? It's just to cool down. Our skin is our heat exchanger. It's our heat sink. Like a computer cooler, heat sink, skin is our heat sink. Basically, it's trying to reject all the heat that because of walking, talking, and doing activities our body generates. All of that is being dissipated from dry skin as well as sweat from the skin. But when you start sweating, like dripping in the sweat, it's because air surrounding you is not capable of absorbing all that moisture. It's already saturated. And that's what the next slide is. When relative humidity is 100%, air is said to be saturated. Air is said to be saturated. Now, what is meant by relative humidity? What is meant by relative humidity? What do you guess? I mean, I'm not asking you a textbook definition, but what's your guess? So, we have seen what is humidity ratio or specific humidity is the amount of water vapor every kilogram of dry air. Also, grams or kilograms of water vapor every kilogram of dry air. That is your specific humidity or humidity ratio, absolute humidity. These are three different names for the same property. What's meant by relative humidity? The word relative means relative to something.
Pressure. Pressure.
Relative to kind of pressure, but relative to more, no, relative to the maximum amount of moisture that can be present in the air. Okay, so imagine, let's imagine, or let's forget about air. Let's focus on an analogy of this classroom. So there's a limited number of seats in this classroom, right? So there are a few empty chairs. I've got